Good morning, everybody. I hope you're ready for another exciting morning of chemistry, Chem 1105, with your host, me, Dr. White. It's going to be a fun morning. But anytime I can talk about, good morning, Rain. Anytime I can talk about chemistry and get paid a little, they don't pay that much, but still got to get paid, I'm going to have a good time. And I hope you do too. All right, couple things. First of all, let me find what I'm looking for right here. And if you look on the screen and everybody's got their, some of you turn on your webcam. It makes me feel better. You want Dr. White to feel better. You think maybe some guilt will work. Anyways, if you, everybody thumbs up if you see on your screen the Chem 1105 YouTube channel. And you'll notice right here, the first one, 2021 0615, Chem 1105, which I click on it now, was yesterday's Zoom meeting. And it's on YouTube. Good morning. Let me tell you a little about myself. In fact, see, it sounds just like me. That was hokey. But anyways, this is now available, and today's will be put up sometime today or tomorrow for you to use. So I just want to make that you aware of all that. Now, important thing, remember, in my class, there's no such thing as a dumb question. If you have questions, ask them. I'm not one of those faculty members who get all upset because you ask questions. No, that's what you're here to do, learn. How do you learn if you don't know it? You ask questions. Also, a uh, uh, commercial or message from the management, public service announcement from the management me. Tonight, I will have my office hour from 6 to 7:15. It's a different logon. The logon is both on Blackboard, and it's also in my syllabus, which is available to you on Blackboard. If you have any questions, come on by, say hello, and I'll help you. I do not and never have and never will record my office hours. Also, just so you know, if you stay after class and ask me questions, I cut that. I like that. Cut that out of the video because I have video editing software, Adobe Premiere Pro, which I am now pretty good at. All right. Did anybody happened to be outside yesterday afternoon or evening, early evening to enjoy the beautiful weather? And if you did you feel the wind on your face or your body and think about those are molecules hitting you? Or when you were breathing since our meeting last time, hopefully you still are. Uh-oh, bad humor Wednesday. But did you think about when you inhaled and exhaled? That was a gas, and the gas has indefinite volume, indefinite shape. It's one of the three states of matter. Remember, solid, liquid, gas. And you think about the air around you as a mixture of oxygen, nitrogen molecules. It is. It won't hurt to think about chemistry outside our get together because chemistry is all around you. I stole that from SpongeBob, the one where you get imagination. Except when I do it, there's no rainbow. Shucks. But anyways, let's get to work. But first, let me find the right one. All right, yesterday we were talking about temperature scales. And remember, there are three temperature scales. One is Celsius degrees C. Sometimes I'll say centigrade, but I've been getting better lately in the last couple of years. K is for Kelvin. It's not degrees Kelvin, it's Kelvin. It's an absolute scale. And F is for Fahrenheit. And I showed you these conversion scales, which we did the first one. We worked on the second one. Notice I say we, I did one, and you tried one. And I just did the last one. So let's do the last one. Kelvin is equal to degrees C, Celsius, plus 273. Now, later today and tomorrow, you'll understand what I mean by 1.832 and 273 are exact numbers and not used to figure significant figures of the temperature. We'll get to that probably today. So, Tina, I'll try it. I just realized you asked that. I'll try to do that. Uh, this one I won't, but next one I will. And why don't you try this one? If a gas has a temperature of 102 degrees C, then what is the temperature in Kelvin? And why don't you try that? Remember I showed you yesterday, when you're doing a problem like this, put down what are you being asked to find, and then what are you given, and then solve it. And when you're done, give me a thumbs up. And while you're doing that, I'm going to take attendance by looking at everybody who's here. I see somebody already beat me to the answer. Let's do this. So the first thing is, what are we trying to find? Kelvin. What are we given? 102 degrees C. Once I've done this, I don't have to look at the problem again, and it makes my life easier. And I like to make my life easier. Now, in important information at the end of test number 1, you'll see the following equation or conversion. And I know degrees C is 102. And I'll do the addition, and I can do this in my head, but make sure I did this right. And that's your answer. And that's how you do it. And we did that yesterday. And I see some people, uh, the first test, I'll have to look it up, but it's in the syllabus. Uh, ask me that after class, Disha. I hope I'm pronouncing your name correctly. But it's coming up in a couple of weeks. We've got time. And that's how you do it. And if we go back to chapter 1, information, first of all, know how to use these. We'll be going through chapter 1 practice later on. Thank you, Colton. It's 7/1/21, otherwise known as the 1st of July. I appreciate everybody's help. And that's how you do it. And if we look here, oh no, guess what? We've reached the end of chapter number 1. And you know what that means? It means it's time for a new chapter. It's time for new stuff. Now, one of the things with the book, I was going to pull it out, but you don't have to even buy it, so I'm not going to pull it out, is the order of the chapters are not the best for you to learn chemistry. And since I'm a chemist and I also know how to teach chemistry, at least I think I do, I hope I do, because of that, I've changed the order. We're not going chapter 1, 2, 3, 4, 5 like that. We're going to do something a little different. And it's in the syllabus. So right now, the next chapter will be the appendixes that we will do. Thumbs up, people. Do you see Appendix A2 and A4 on your screen now? Give me a thumbs up. Thank you. All right. Now, let's talk about measurements and problem solving. And I will never ask you what is a measurement, but I will tell you measurement is the determination of dimensions, capacity, quantity, or extent of something. You don't think about it, but when you go to the gas station and pump in some gas into your car, or you're with someone who does that, the pump is taking a measurement. It's telling you how much gasoline volume, how many gallons you put in the tank, and then they also calculate how much money it costs you. By the way, the price of gas has gone up. But look at it this way. You don't have to commute to COD. Think all the money you're saving in gas this summer. For me, it's a lot because I live in the northwest suburbs, and to get to COD, it's about a half-hour drive each way. But anyways, those are measurements. The next time you listen to the weather, when they tell you the temperature, humidity, or barometric pressure, and we'll talk about barometric pressure and humidity later in the semester, those are all measurements. All right. All right, now can everybody see measurements and problem solving? Okay, all right. And that's a problem with Zoom, that sometimes I think I'm showing something and it tells me I am, but I'm not. And that's why I do the thumbs up. All right, now chemists measure many things. I'm not going to ask you what things chemists measure on the test. Oh, speaking about tests, as you know, I teach by my golden rule. I never do on to students what I didn't like done to me when I was a student. And when it comes to my tests, listen carefully. Every question on the test, any of my tests, and the final, I'll cover the concept behind that question at least twice in lecture, usually a lot more, but at least twice. So if I didn't cover it in lecture, it won't be on test, except for one thing I don't cover in lectures that will be on the test, and that's where you put your name. All right, so chemists measure many things. One of them is mass, and you think of that as the term weight. And since I established yesterday, for the summer at least, we all are going to stay on the planet Earth, so you can use mass and weight interchangeably. Another one is volume, how long it is, something is, how much time something takes, temperature, pressure, like the pressure in your car uh, tires, concentration, which is how much of one substance is in another. I'll talk about that when we get to solutions, and other physical and chemical properties. You don't know about it, but next time you're in a gas station, the octane number is a measurement of how bad something or well something burns, and a measurement that's quite important. I'll teach you near the end of the semester, pH. Plus, we measure a lot of other things. Just an example, a very important measurement is color. What's the color of something? I worked for chemical companies who sold to various consumer goods or cosmetic companies, Neutrogena, Procter and Gamble, Lever Brothers, or Unilever, it's now called. And their products, certain of them, when you buy it, you expect it to look a certain way. And part of the way it looks is the color. And there are a number of color scales used to measure. Let me just show you one. Can everybody see these test tubes? Let's see if I can find a better one. This is the one I was looking for. Everybody see the little vials on the left of your screen? Give me a thumbs up if you can. All right, let's try. All right, thumbs up, people. Help me. Do you see the APH standard liquid in the upper left hand of your screen? Thank you. And if you notice right here, let's see if I can get it bigger. Here, this is the APH, and they have standards. And this is APH 0, APH 100, APH 500. Notice goes from almost water white, clear, to a slight yellow. And in contracts, companies will state the product you sell them has to be APHA 100 or less, because it's got a slight yellow tinge to it. Do you want to buy something that's normally clear and all of a sudden it's got a yellow tinge to it? No, there's something wrong with that, you would think. And the companies who sell stuff like that know that, and that's where they measure color, which is a measurement. So chemists measure many things. Now, when we measure things, we get numbers. And one of the important things in chemistry is using what's called scientific notation. I'll never ask you what scientific notation is, but I'll expect you to know how to use it. And I'll be teaching you that right now. But first of all, what is scientific notation? It's a system which an ordinary decimal number is expressed as the product of a number between 1 and 10. It's never less than 1, never 10 or more, times 10 raised to the power. And it looks like this. Some number between 1 and 10, never less than 1, more than 10, times 10 to the n. Now, let's talk about 10 to the n. What does that mean? 10 squared means 10 times 10, which is 1,000, 100. Got to step ahead of myself. 10 cubed is 10 times 10 times 10 equals 1,000. And 10 to the 6th is 1 million. And you can have very large numbers. Number we'll be using a lot later on is called Avogadro's number. 6.02 times 10 to the 23rd. And if you had to write a 6 and a 0 and a 2, and then 21 zeros after that, that would take a lot of time and space. Notice this is much easier to write, and that's a huge number, a huge number. So scientific notation allows you to write a huge number in a very small space and easily and quickly. So how do you do this? And I'll never ask what are the ways of doing it, but I'll expect you to know how to do it. We'll practice it. Now, converting decimal to scientific notation. The decimal point in a decimal number is moved to the position behind, which means to the right of the first number. So and I'll show you this in a sec. See a question? Dina, I'll be doing some in a little while. Let me go through this. I always do a number of examples, and if not, ask me to. Okay. All right. The exponent for the exponential term is equal to the number of places the decimal point is moved. And the exponent is positive if the number is 10 greater than 10. The exponent is negative if the number is less than 1. If the exponent is 0, which I never use and chemists never really use, is 0 if the number is between 1 and 10. So let's do some practice converting from decimal to scientific. Now, I used to have students go back, but you never use that, so I'm going to skip that part. So let's do some practice. All right. One of the problems when I have so many things open on this PC. And as you notice, I am printing it. All right, write the following in sci-fi scientific notation. Sci-fi, my mind's on what I want to watch tonight. No, that's not what I want to do. Hold on. Oh, what did I just do? There, I'm not going to cheat you in notation. So let's do our first one. That's 5,100. How do you write that in scientific notation? Well, if there were a decimal point, in this case there isn't, it would be right here. And you move it to the right of the first non-zero integer. So 1, 2, 3. So I have 5.1. There's zeros at the end with no decimal. Remember, there was no decimal. I put it there. You drop the decimal, no decimal point, you drop it. So what's n? 10 to the n. How many times did I move it? 1, 2, 3. This number is greater than 10, so that would be 5.1 times 10 to the first. Don't worry about it, Dina, not your bad. All right, let me show you another one. Nope, I used 5 already. By the way, 5 is my favorite number, so is 10. Actually, a million would be favorite. A billion would be better, especially for dollars. My dollars. Oops, I don't want to do that. I might have mentioned yesterday, but I'll mention again. When in high school, when I was taking German, we had our instructor, teacher was actually from Germany, Herr Brink. I still remember his name. He was quite good. And he would write his 7 like that, the German or European way. I thought that was the coolest thing in the world. And ever since then, I still think it's the coolest. So that's why I write my 7s. Question is B, write this in scientific notation. How do you do that? If there were a decimal, it would be here. You move it to the right of the first non-zero number. 1, 2, 3, 4, 5, and it'll be there. Any zeros at the end when there's no decimal, you drop. And I moved it 1, 2, 3, 4, 5 times. And that's times 10. And n, the number here, would be 5. And that's how you do scientific notation for a number greater than 10. Now, I'm going to let you have some fun. Why don't you write that number in scientific notation? 3 points each. And when you're done, give me a thumbs up. All right, anybody need more time? Well, in that case, I'm going to get going. If there were a decimal, there isn't, but if there were, it would be right here. This number is greater than 10, way greater. And now I'll go 1, 2, 3, 4, 5, 6. Any zeros at the end, I'll drop. So it's this times 10 to the n. 1 is n. I moved it 1, 2, 3, 4, 5, 6, 10 to the 6. So that would be your answer. And Rain corrected herself. Oh, let's do one more. These are nice. And here's one more for you to try. Write that in scientific notation. And when you're done, give me a thumbs up. Use the emoji for Zoom. I've been I'd like to get the world to call it, not emoji, call it symbolic. It's a symbol. We are doing more examples. Now, one of the things I haven't finished yet, but at a certain point I have to move on. And the way I teach this course is I do a couple examples and then we'll do more when we go over the problem set, which we'll do in lab days. Remember, lab days are Tuesday and Thursday. Oh, tomorrow's going to be a lab day. Yay. If you haven't gotten Beyond Lab Z activation code, I'd recommend you order it soon because you'll need it next week. You won't need it tomorrow, but you'll need it next Tuesday. All right, anybody need more time? Nobody's yelling at me, so I'm gonna go do that. Let me, before I see. All right. If there were a decimal, there isn't, it would be there. We'd move it 1, 2, 3, 4, 5, 6, 7, 8. Moved it 1, 2, 3, 4, 5, 6, 7, 8. Now all zeros at the end when there's no decimal are dropped. So I have 4.567 times 10 to the end. What is n? How many times we moved it? And that's 8. And that's how you do it for a number greater than 10. Well, let's do one less than 10. And here, I'll do this one. Now here we do have a decimal. Now one habit and good habits I don't change is on the left of the decimal, I like putting a 0. If you were to put it like this, that's okay, but on a test, I'd always write it like this. Well, what do? You move the decimal to the right of the first integer, i.e. that is non-zero number. So we'll do 1, 2, 3. Any numbers after the decimal, including zeros, when it's less than 0, you keep. But the lead zeros you drop. So this will now be 3.21 times 10. Now, when the number is less than 0, n is negative. When the number is less than 0, which this definitely is, n is negative. How many times did we move it? 1, 2, 3. So it's negative, and it's 3. So that'd be 3.21 times 10 to the minus 3. Now, me do this one again. And I'll let you try a couple too, because I share. I don't want to hog all the fun. If I say fun enough times, you'll believe me. All right. What do? You move the decimal to the right of the first non-zero number. 1, 2, 3, 4, 5. So this number is less than 1. Any zeros after the decimal, where the decimal after you move it, are kept. So this would be 5.20 times 10. Now, how many times do we move it? 1, 2, 3, 4, 5. It's less than 0, so it's minus 5. And that's how you do it. Thank you. And I'm glad everybody's jumping in on chat if they feel like it. And now here's one for you to try. Why don't you write that in scientific notation? 3 points each. In case you can't see it, it's sort of tiny. I'll go to a larger font for a decimal point. I see everybody's getting into the spirit of this. Thank you. All right, let's do it. How do we do this? You move the decimal point to the right of the first non-zero number. Ooh, Dr. White's getting serious here. And here's our decimal point. 1, 2, 3. We moved it 3 times. This number is less than 1, so n is going to be negative. So that would be 4.96 times 10 to the nth, and it's going to be negative. We moved it 3 times, 10 to the minus 3. Oh, let me do one more. Or I should say, let you do one more. Why don't you write that one and let me increase the font of my decimal point right there. Write that in scientific notation. And while you're doing that, give me a second. Bingo, found it. Ah. And let me start, but first I'll check the chat. I see a lot of you have already done it, and let's do it. All right, now I wrote this for a reason. Remember, first of all, what you're going to do is move the decimal point to the right of the non-zero number. 1, 2, 3, 4, 5. Zeros at the end after the new decimal point are kept. So this would be 9.300 times it's less than 1. So it's a negative number times 10. How many times do we move it? 1, 2, 3, 4, 5. Oh, my favorite number, 5 times 10 to the minus 5th. Remember, zeros at the end of the number after the decimal point, like here, are kept. If they're in front, they're not kept. If it's a number greater than 10, where there's no decimal at the end, then those are dropped. And that's how you do scientific notation. Now, sometime probably next Tuesday, I will be going through the problem set for this chapter, maybe not Tuesday, maybe Thursday, and you'll have a chance first on your own to do some of these, and then I'll go through it in our Zoom meeting, the ones I have in the problem set. At that time, if you have any questions, that's the time to ask, or now too. So now, in the old days, before calculators, and I better fess up to something. You know how, oh, that reminds me, public service announcement from the management, me. Tomorrow in lab, I'll go through how to use a scientific calculator. This is the best one to buy because it's cheap and it works well. But if you got a fancier one, that's fine. If you have a calculator after tomorrow, you have problems using, like doing calculations in scientific notation, come to my office hour or come early to class. There's yet to be a hand calculator I haven't figured out using the manual too, and all of them are online. You can find them with Google, that I haven't been able to show the student how to use it. But these things are super simple to use and they're durable, they're inexpensive, they're good. Oh, by the way, I don't get any kickbacks from TI. I wish I did, but I don't. But tomorrow I'll do that and I'll be teaching that. Another thing which I forgot to mention, let's see, when would be a good day? Next Tuesday after lab, I will teach anybody who wants to stick around. It'll only take about 10, 15 minutes. I like those hand signals. But anyways, years ago, I developed a method based on somebody else's method, how to eliminate test anxiety. If you get real nervous during a test, and you're going to be taking tests in my class as part of college and a final, and all of a sudden you know how to do it, but during the test, all of a sudden your brain goes, "Ooh," and that happens to a lot of people. It's surprising. I found out I've developed a method that eliminates that, and it works quite well. I've had students in my chemistry classes as COD and ECC, Elgin Community College, have gone from getting F's, D's, and barely C's to be high B and A students. It works. I do cut it out of the video, and if you can't make the class, you can always come to my office hour, but I'll do that next Tuesday. Oh, I know the other thing I was going to say. I lost my train of thought. It pulled out of the station before it came out of my mouth. But anyways, back when I was in grad school, and this was in the mid 1970s. Yes, I'm that old. But anyways, the first handheld calculator by Hewlett Packard, HP, first came out. I think it was my third year. I want to say about 1974. And they cost about $500 for a hand calculator. And then a good salary for somebody making a lot of money was only $24,000. So that was quite expensive. I remember one of the grad students I knew bought one. He was a physical chemist who did a lot of calculation. And we all were looking at it like drooling. I wish I could spend the money, but I'm not. And I had a slide rule, I still have it. That was my graduation gift from high school from my parents, which cost a lot too. But because we now have calculators, you don't have to know, but I put it down for nostalgic reasons. The following: if you're multiplying 10 to the A times 10 to the B, you want to do it in your head, it's 10 to the A plus B. And you need how to do that if you're using a slide rule. With our calculators, you don't. If you divide 10 to the C by 10 to the D, it's 10 to the C minus D. Now, if you're using a slide rule, you need to know these. But with our calculators, no, you don't have to know that at all. And yep, they were quite expensive. Oh, speaking about expensive, for those of you who want to get wowed again, back in, when was it? I think it was 88 or 89, I bought my first home PC. I'd already been using them in work where I was able to finagle having them buy one for me. But I got my first PC, it was an HP PC, and it cost me about $4,500. And back then I was making a good salary. Back then about 65,000 a year and almost $5,000 for a PC. They were expensive. Now you can go out and buy them for under 1,000, good ones. I have a guy who builds them for me every couple of years, and they're under 1,000. I get a lot of stuff put in it. All right, let's get back to chemistry. Now, when you measure numbers like how many milliliters are, what the volume is in a bottle, how much does something weigh, when you measure something, numbers you obtain when you measure a quantity, such as weight, length, or temperature, other things. There's always uncertainty in every measurement. And science has come up with a way of dealing with this uncertainty. In any measurement, the last digit is always uncertain. You got to guess about it, but it's only the only uncertain digit. So that means when you take a measurement, some of it is uncertain. It's a guess. And because that, it was developed the concept of significant figures. Significant figures are the digits in any measurement that we know for certain, plus one digit that's uncertain. Now, that's when you take a measurement. Now, there's another type of figure or number we call exact numbers. And these are numbers obtained from counting items or from a definition. Example definition are the formulas I gave you for converting from Fahrenheit to Celsius, or Celsius to Fahrenheit, or Celsius to Kelvin. Those are definitions, and the numbers were like 1.8, 32, or plus 273 are exact numbers. Now let's take a look at what this means. Thumbs up, people. Does everybody see on the screen what are significant figures? Help me out, people. Thank you. All right. Now, notice the first ruler only measures 0 to 100 centimeters. So if we have this, how much is it? Well, I'd guess I can only get one significant figure. I'd say it's about, maybe 20, 25. So say I call it 25. The first one I know pretty certain, the last one I'm guessing. Now here, the second ruler, notice the measurements are every 10 on the ruler. So I can get, this is 20. I could say that's about 21. Now on the last ruler, it's more accurate. I can't blow it up anymore. And the line is 1, 2, 22, and it's halfway between 22 and 23. So I can say that's 22.3. So this was like 20 or so. So that'd be one significant. This was like 22, 2, and this was 22.5, 3 significant figures. The more significant figures you have of something, the more accurate it is. And that's this part of life. When you measure, the device you measure with, the accuracy determines how many significant figures. And if you go to COD, we have balances that can weigh things to 6 significant or 8 significant figures, very accurate. I've worked with balances that go real accurate, and they're so sensitive. If somebody walks by while I'm weighing it, the weights change from the vibration of their footsteps. Don't walk by, I'm weighing something. And even the wind in a room will change the scale. So Significant figures, let's take a look. Significant figures, exact numbers. Now let's talk about exact numbers. If we're in a classroom and I had 10 people in there, I'd say, how many people are in here? Well, you count 1, 2, 3, 4, 5, 6, up to 10. You can't have 10.5 people are alive or 10.7. That's an exact number. If I asked, went out and bought a dozen eggs, 12, and I asked how many eggs are in the carton, you're not going to say 11.5. You can't have half an egg. You have exact number, 12 eggs in a dozen. Unless one's broken, don't forget to check your eggs before you buy them. That's a public service tip from Dr. White. Oh, I apologize. I got so fired up. I went past. Let's go another 2 minutes and we'll take our 5-minute break. So we have significant figures and exact numbers. Now, how do you determine significant figures? There's a series of guidelines. Will I ever ask you what are the guidelines for determining significant figures? No. Will I ask you how to use, that you should know how to use these? Yes. I'm going to go through some examples. We'll practice it. And I also have practice problems we'll do later. You'll do, and we'll go through it. All right, let's go through the first one right now. All non-zero numbers are significant. So when you have a non-zero number, they're significant. Let's take a look real quick. And the question is, how many significant figures are in 157? Well, they're all non-zero numbers. So we have 1, 2, 3. So the answer is 3. And with that, it's time to take a break. I'm going to go stretch. I'll see you in 5 minutes. Come back at 10 o'clock. Sorry, went over 5 minutes. I got all carried away with significant figures. And I'll see you in 5 minutes. I better get back to work. Time to get back to work. All right, we're talking about significant figures. And all non-zero numbers are significant. Therefore, if I ask this one, how many significant figures are in B, the number in B? I'm going to let you try it. Your turn. All right, time's up. And put down your pencils, hand in your test. No, I'm just practicing. No. All right. All non-zero numbers are significant. And these are all non-zero. So this is 1, 2, 3, 4. And that's how you do it for non-zero numbers. Let's continue our learning, or your learning, because I already know this. Now, all non-zero numbers are significant. Zeros may or may not be significant. Wow, that's helpful. Not. Now, this next couple ones may seem a little confusing at first, but we'll practice it. So relax. Lead zeros at the beginning of a number are never significant. What do we mean by that? This number. How many significant figures are in there? Lead zeros, not significant. Non-zero numbers are. So this is 1, 2. So that would have 2 significant figures because lead zeros are never significant. And we'll practice all this once I get through this list. You'll see. All right, confined zeros, those between non-zero numbers, are significant. And what that means is if I have this, and the question is how many significant figures is in that number, 1035. Now, all non-zero numbers are significant, 1, 2, 3. So there are 3 non-zero numbers. Notice this 0 is in between non-zero numbers. So it also is significant. And the answer is 4 significant figures. And all non-zero numbers are significant, and zeros between those between non-zero numbers are significant. Now, trailing zeros at the end of a number are significant if a decimal point is present in the number. So if I have this number, notice we have a decimal point. Trailing zeros with a decimal point are significant. So this would be 1, 2, 3, 4 again. Let's do another one. And now here we have a 0 on both sides of the decimal, but because we have a decimal point, all these zeros are significant. So this would be 1, 2, non-zero numbers are significant. Zeros at the end with a decimal are significant. So it would be 3, 4, 5. This would have 5 significant figures. We will go through examples, all this when I finish. Trust me, I'm a chemist. Does that work? All right. Trailing zeros, those at the end of a number, are not significant if the number lacks an explicitly, and the key point here is explicitly shown decimal point. So if I were to do this, how many significant figures are in that number? 1400. All non-zero numbers are significant. Oh, look, I have trailing zeros. And whoever asks a question, I'll get to you in a second. I'll check the chat. Let me finish this. Now, is there a decimal? And the answer is no. So trailing zeros with no decimal point are not. So the answer to that would have two significant figures. I see somebody's working with me. Thank you for everybody who's answering. All right, let's have some practice time for these, and I'll do some, and then I'll let you do some. So let's continue. How many significant figures? Depending when I write the test, 2 or 3 points if I put this on the test. And I'll let you try this one. How many significant figures are in that number? Remember, all non-zero numbers are significant. Time's up. All non-zero numbers are significant. There's 1, 2, 3, 4, 5. So the answer is 5 significant figures. Let's see if what's on the chat line. And there you go. It's just 5 significant figures. Significant figures, when I ask for that, those are exact numbers. So let's try another one. Remember, lead zeros are never significant. Oh, I see people are jumping in. Thank you. All right, let's take a look at this. Lead zeros are not. So I ignore this, I ignore this, I ignore that. All non-zero numbers are significant. And that means there are 3 of them. And that has 3 significant figures. Let me redo this one. Now, confined zeros are significant. So in C, how many significant figures do you have? Oh, good news. A lot of you getting the hang of this. And if we look at this, non-zero numbers are significant. 1, 2, 3, 4. Now I have 2 zeros. When they're confined, they're significant. So 4, 5, 6. So it's 1, 2, 3, 4, 5, 6. And the answer is 6 significant figures. Oh, this is fun. Let's do some more. And the question is, how many significant figures are present in D? Remember, zeros at the end, no decimal, are not significant. All right, let's do it. All non-zero numbers are significant. 1, 2. Is there a decimal point there? No. So all zeros at the end with no decimal point are not significant. So the answer here is 2 significant figures. Let's try this. Let's do another one. How many significant figures are in this number? Zeros at the end with a decimal point are significant. Isn't it nice that I get to let you have some fun doing this stuff too? See what a swell guy I am. Nice person. All right, let's do this. All non-zero numbers are significant. We have a decimal point. Zeros at the end are significant when we have a decimal point. So these are 2. So it'd be 1, 2, 3, 4. And this would have 4 significant figures. Now let's wrap it all together and do a couple more. Assuming I know my alphabet. Sometimes I do. How many significant figures are this? Hint, you ignore 10 to the power and the letter X. Yeah, I see everybody's done, so let's take a look. This part in scientific notation, when you're doing significant figures, you ignore. But this part you use. And all non-zero numbers with or without a decimal are significant. So that'd be 1, 2, 3. That would be 3 significant figures. And let's do one more. Yeah, I think everybody's done. I'll give you another 4.75 seconds. 1, 2, 3, 4, 4.2, 4.6, 4.7. I got a slow watch today. Time's up. All right. All non-zero numbers are significant. 1, 2, 3, 4. Notice we have a decimal point. All zeros at the end with the decimal point are significant. So that would be 1, 2, 3, 4, 5, 6. It's 6 significant figures. Oh, let's do a couple more because these are fun. Ooh, this is a good one. How many significant figures are in this number? Remember about lead zeros are not significant. Confined zeros are, and zeros at the end are when there's a decimal present. I have used this today yet. Oh no, this doesn't have one. I'll have to make some questions up for tomorrow. All right, I think everybody's done. Anybody need more time? Nope. So all lead zeros are never significant. So this is not, this is not, this is not. We have a decimal point. All non-zero numbers are significant. Zeros that are confined and also after a decimal point would be significant. Zeros at the end with a decimal point after the decimal point are significant. So this would have 1, 2, 3, 4, and the answer is 4. Let's do one more. And the question is, how many significant figures are in that number? Oh my goodness. A number of you are getting the hang of it. Doesn't that feel good? I hope it does. All right. Anybody need more time? Let's do it. All non-zero numbers are significant. 1, 2, 3, 4. Confined zeros between two numbers that are non-zero are significant zeros. So this would be 5. There's no decimal point. PT is shorthand for point. So these are not significant. So this has 1, 2, 3, 4, 5. So the answer is 5 significant figures. And that's how you do it. Now, there's an important concept called rounding off numbers. And this is the process, and I'll never ask on tests what's rounding off numbers, but I will expect you to know how to do rounding off numbers. And rounding off numbers is the process of deleting unwanted, otherwise known as non-significant figures from a calculation. And I'll be teaching you what happens during a calculation this morning also. Now, the rules, the first digit to be deleted is 4. If the first digit to be deleted is 4 or less, simply drop it and all the following. And it's slightly different between numbers greater than 1 and less than 1, and I'll go through that. Or past the decimal. The first digit, if the first digit to be deleted is 5 or greater, then that digit and all that follows are dropped, and the last remaining digit is increased by 1. So these are the rules. You look at the first digit you want to drop after the last significant figure, and if it's 4 or less, you drop it. If it's 5 or greater, you increase the one in front and then drop everything or replace it with zeros. Let's look at examples. That's not an example. And this is an important skill you'll need along with how many significant figures a number has for test number 1, 2, 3, 4, and the final. Because on all my tests, it will say underneath your name, please use proper significant figures for all calculated answers. If you don't, I take off a point for each problem. I've had students lose 5, 10 points because they don't do it. I'll teach you how to do it today. All right, most of the time you're going to be dealing with a number between 1 and 10. So let's do some, and then I'll do a couple others too. So this is, let me write it a little better. How do you round 1.246 to 3 significant figures? It has 4. So you keep the first significant figure, the second, the third. This is the number you're using to round off. Is that 4, less, or 5 or higher? I hope we all pick 5 or higher. Therefore, I'm going to drop that and the number in front of it, and anything that was past it, I drop and increase the 1 in front by 1. So this rounds off to this, 1.25. And the question would be, how do you round this off to 4 significant figures? Well, you keep the first non-zero number, the next one, the next one, next one. That's 1, 2, 3, 4. This is the number next one after the last number you're going to keep, used to round off. And notice 2 is less than 4 or less. So this all gets dropped, including the numbers past it, and the number would be 2.34. And that's 4 significant figures. Why don't you round this number to 2 significant figures? I'm going to let you have some fun too. All right, I think everybody's done. So I better get to work. We're rounding it off to 2 significant figures. You keep the first non-zero number, the second non-zero number. That's my first and second significant figures. And then we're past the decimal. The number to round off is 6. Is that 5 or higher, 4 or less? Hopefully I'll pick 5 or higher. Therefore, I'm going to drop this and anything past it, increase this to 1, and the correct answer would be that, 2.3. Let me show you how to do a number that's greater than 10 and less than 10 without scientific notation. Then we'll do one more with sign. Now, this is a number that's greater than 10. And you do the same thing. First non-zero number I keep, second, third. This is the number to round off. Now it's 4 or less. When it's greater than 10, like this number is, anything and everything afterward is converted to zeros. So this would be changed to 0, 1, 7, 5, 0, 0, 0. And think of it this way. If I have 175, 175,400, what are the two numbers to 3 significant figures? You have either 175,000 or 176,000. This is less than halfway, So you drop it to that. That's just how you do that. But most of the time, you're going to be using a calculator like all of the time. So you'll get numbers like that. And let's go back and do another number. Why don't you round that off to 4 significant figures? I haven't done it, but everybody done? Thumbs up, people. I got to train you people who don't turn on your webcam. Do a thumbs up with your emoji. Thank you. All right. How do we round this off to 4 significant figures? Keep the first non-zero, second, third, fourth. We use the next number, this, to round off. Is that 4 or less or 5 or higher? And the answer is it's 5 or higher. So that and everything else past it, because I'm past the decimal, I'll drop, and this I increase by 1. So that's 2.769. And that's how you do it. Now, let's talk about a real tricky case that I almost wrote up here. Let's do this one. How do you, and this one I'll do. How do you round this off to 4 significant figures? I keep the 1, 2, keep the 7, that's second, 6 is 3, 9 is the 4 significant. I use this to round off, is 5 or higher, so I can drop that, and everything else increases by 1. Well, what happens when you increase that by 1? 9 becomes the number 10. So this goes to 10, which means this increases by 1, but this 0, then when this becomes 10, I keep. And notice this new number, how many significant figures? Well, you know how to do that. All non-zero numbers I keep, and zeros after decimal I keep. So that does have 4 significant figures. So when you have to increase the 9 by 1 and it's past the decimal, the number in front that you're also going to keep increases by 1, and this 9 becomes a 0. And why don't you round that off to 3 significant figures? 3 points each. All right, everybody's putting in their numbers in chat. So I think everybody's done. And the question is, how do you round that off to 3 significant figures? You keep the first non-zero number, 4. The second one, 7. Third, 9. So those are my three significant figures. To round off, you look at this number. And I used, I don't know, when I started a couple of years ago, putting double squiggly line like that underneath the number to use to round off. And that's a 7. Is that 4 or less or 5 or higher? And the answer is it's 5 or higher. So I'm going to, since I'm past the decimal, I'm going to drop that, drop that, drop that, increase that by 1. But that becomes 10. So I also have to increase that by 1. But I keep the 0, excuse me. And notice this number has 1, 2, and a 0 at the end with a decimal is significant 3, which is what I want. Oh, let's do one more. And why don't you round that one off to 3 significant figures? Now, you'll find out Dr. White gets in his 3 figure rut. Why? Because the slide rule is only good to 3 significant figures. And I got brought up on a slide rule. And a lot of people from my generation just know you 3 significant figures for most things are good enough. I've done calculations that have involved, if I did it wrong, I've just blown close to $250,000 in chemicals, and I only use 3 figures, and it works fine. All right, I see it. Well, all of you are done. Let's take a look at this. We want 3 significant figures. Now, keep the 5, keep the 1, keep the 9. Those are my 3. The number to round off is 2. Is that 4 or less? I hope you all say yes. So that's my round off. We're past the decimal. I round that, drop that, drop that. Since 2 or less, I just drop it, and you get 5.19. And that's how you do rounding off. Now, one of the questions you might want to ask, and you should, is why am I learning significant figures and rounding off? Well, it turns out they're important in our daily life. How important? Well, let me tell you a story. A number of years ago, I worked for a company, Axo. It was then called CHEMI. It's now called AkzoNobel, and that division was split off and it's now called Nurion. Anyways, I worked for CHEMI. And we bought chemicals from a certain company. And when you buy chemicals, there are things called specifications. When you go and buy, say, a new car, and you want a certain car, you're going to have in the contract or whatever you sign specifications. Like, do you want 2 or 4 doors? What color do you want? Those are all specifications. Well, in chemicals, when they're being sold, there are various specifications. Now, at that time, we bought certain chemicals from this other company called Unichem Chemicals, and we were having problems with it. And part of my job at that AkzoNobel was to solve plant problems. I saw the problems they were having, and we tracked it down to the purity on the chemicals we're getting from Unichem weren't up to spec, meaning they didn't meet the specifications. At that point, you can just send it back, but we were using it already. So I went and contacted the people at Unichem and said, you got some problems, so we want to buy from you. So I actually went down there and helped them solve their problem. Well, they were moving all their operations. They had bought a company in Chicago to also help make their products. And because of the way I impressed them, they wanted me to be their laboratory manager. At first I said no, and then they made me an offer I couldn't refuse. They doubled my salary. Yep, double. I was making good money at Akzo. Now I was going to make real good money. So anyways, now I was at the company shipping to my former company. At the former company, I knew everybody there because I worked with them in my position, especially at their largest plant in McCook, Illinois, Morris, Illinois. They used to have one in McCook too. But anyways, one product had a specification. It's called iodine value. It measures a certain important feature of a molecule. And the specification in the contract, and people at Unichem was smart and people at Axle were dumb when the purchasing agent, the iodine value, which is abbreviated, had in the contract, it was 97 minimum. However, when you measure iodine value, you can measure it to 3 significant figures, always. So we shipped something, actually 4 tank wagons, of a chemical. This is called a fatty acid, oleic acid, I think it was. And our measurement for IV was 95.5, which meant we were above the minimum. And Axo, people I knew, got 94.7 or 8. I forgot exactly. Now, let me show you about tank wagons. These are real cars that are not tank wagons. So let me just try this. Well, this is a smaller one. Let's see if I can find one. Nice train, but normally I can find one real quick. All right. How many of you are familiar with the vehicle that delivers gasoline to a gas station? You know, those big, long vehicles? Those are tank wagons. Tank wagons, whether they deliver gasoline, chemicals, or milk, are standardized. They're 5,000 gallons, 40,000 pounds. Well, we had just shipped 4 tank wagons of this product where we said the iodine value was 95.5. And the quality control manager, by the way, anytime you ship from a company, chemical, it has a document called the Certificate of Analysis, sometimes called C of A, sometimes called CERTS, depends which company you work for, how they acronym they use. And it gives the specifications, the measurements, and it's signed. I had to sign them as the laboratory manager, and I signed it. And I wasn't too happy it was so close to the minimum, but I knew it was over it. Well, anyways, the quality control manager from Axo, who I knew quite well when I worked at that company, called me up and he knew me. He said, we're going to reject these tank wagons. 4 tank wagons, 50,000, 40,000 pounds. That's 160,000 pounds at $1 a pound. We're talking a lot of money, $160,000. We don't want it. I said, you can't. He said, well, it's below spec. We got 94.7 or 8. I forgot. I said, well, we got 95.5. He said, well, we got it below. We're going to reject it. I asked him, do you have a copy of the contract in your office? Which I knew he did. And I had a copy. And he said, yeah. And I said, how many significant figures are in the contract for iodine value? And it was 95, 2 significant figures. I said, take your number and round it off to 2 sig figures. And he got real mad and said, it's 95. I said, mine rounding it off is 95 and a half. I could say 96, but it's still above 95 or greater. You have to accept it. And he went ballistic. I'm not going to tell you the nasty words he started saying to me. And I knew he was upset, and I would be upset if somebody did that to me too. So I said, look, are you available for lunch in a couple of days? I'll come over to Morris. I was located 47th Racine. Let's go out to lunch and I'll talk to you about this. But you got to keep it. And he was so mad, but I said, all right. So when I was in industry at my level, you have company credit cards. I had American Express. On that company, my limit, I think, was $50,000 a month on that credit card I could charge for company stuff. So I was going to take them out. I took them out for lunch, got them good and drunk. I had a few too. That always works in a meeting. I said, I'm sorry, that will never happen again. And then I also, with my boss, had a meeting with the plant manager, and I told him point blank, for this product going to this company, even though the minimum is 95, if it's not 96 or 7, I won't sign the certificate of analysis, and it ain't going out the door, because the company at the gate of our company were guards, and their job was, part of it was to make sure anything tank wagon that left had a signed certificate analysis. Well, the plant manager got mad at me, and my boss said, no, he's right, meaning me, because we don't need that kind of difficulty. And I took that guy out for lunch too. That always works to make people happy. No, I'm not an alcoholic, but I do have used alcohol to my advantage. But rounding off plays an important part. Significant figures play an important part in legal documents. Don't tell anybody I told the story about how to make people happy when they're mad at you. Now, when you have significant figures, oh, by the way, that is a true story. Got to watch out. Dr. White can be sneaky. But anyways, when you do various mathematical operations and you have numbers of different significant figures, there are rules for how many significant figures your answer should be. When you do multiplication and division, you get the same number of significant figures in the answer as the number of significant figures in the measurement that contains the fewest significant figures. Again, for multiplication and division, the number of significant figures in the answer is the same as the number of significant figures that has the fewest significant figures. So let's take a look at this real quick, and we're going to take a break in a second or two, maybe about 60 seconds. Now, oops, I did the wrong thing. Let's do the right thing. All right, notice I have 2.0 times 2.0. And normally 2.2 you say is 4. But no, this has two significant figures. And I'll be using SF for significant figures. So I don't think you want to spend all morning watching me write it out. This has two significant figures. This is only one. So how do you do that? Well, put a decimal point and put a 0. And now this has two significant figures. And that's how you do multiplication. And we're going to come back. It's about time to take our break. Take a break now. I'll see you at 10:55. That's when digital watch says 10:50. let's take a break and I'm going to go stretch my legs. Oh no, I'm running late. Time to come back. Oh, wait a second. Time to come back. My train whistle. All right, we're talking about doing mathematical operations with significant figures. And remember, the number of significant figures in the answer is the same as the number of significant figures in the measurement, meaning the number you're multiplying or dividing that contains the fewest significant figures. Now, where this goes really bonkers is when you use a calculator. Now, I don't know if you can see this. I have 5.12 divided by 2.11. Each one is 3 significant figures. And the number I get is monster long. It's 2.426540248. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 significant figures. Well, if each one is only 3, I have to round this off. And that's where you'll be doing that with your calculator, because a calculator always gives you way more significant figures than you need or that are proper in a calculation. Let me just show you what I did. On my calculator, I divided 5.12 divided by 2.11, and my calculator gave me this number. And the question is, do you write this down? No, that would be wrong. On a test, if you have to do this calculation, 5.12 divided by 2.11, which you're going to do in your calculator, that's the number I'll give. On the test, it will say, please use proper significant figures for all answers. Now, if we look at this one, how many significant figures? 3. All non-zero numbers are significant. I'm going to let you figure out 2.11. How many significant figures does that have? Time's up. All non-zero numbers are significant. 1, 2, 3. That's 3. So our answer should have the same number of significant figures as the number that's the lowest significant figure you're using in your calculation. In this case, they're both 3. So our answer should have 3 significant figures. It doesn't. It has a lot more. So I'm going to let you have the fun. Round this number, 2.426540284. That was a mouthful, to 3 significant figures. I see the answers are coming in. And let's take a look. Keep the 2. We have a decimal. So we keep the 4, keep the 2. I'm going to use, that's my 3 significant figures. I'll use the 6 to round off. Is that 4 or less or 5 or greater? 5 or greater. So I'm going to drop all this, increase this by 1. And so the correct answer for this division is 2.43. Oh, let's do another one. And let me put that in my calculator. Now my calculator gives me this number. And I'll teach you tomorrow how to use a calculator with scientific notation. And the question is, what should this number be with proper significant figures? Now, the number you get in your calculation of multiplication or division, decimal multiplication, should be the same number of significant figures as the number you're multiplying or dividing that has the fewest significant figures. I'm going to help you out. This has 3 significant figures. This has 4 significant figures. How many significant figures should your answer have? And same as the lowest number. So this should have 3 significant figures. It doesn't. It's your turn now to round it off to 3 significant figures. Go. All right, let's do it. What do we round it off? Keep the 4. We have a decimal point, so past it. Keep the 3, keep the 7. I'm going to use the 2 to round off. 2 and every 2 is less 4 or less. So that gets dropped, that gets dropped, yeah, that gets dropped. So that would be 4.37. But don't forget this, times 10 to the first. This part you still keep. And that's how you do it. Let's do another one. Remember, multiplication and division, you get the same number of significant figures as the number that you're multiplying or dividing that has the fewest significant figures. Oh my goodness, my calculator throws at me this number. And I'm going to help you out this one. Next one I won't. Oh, Dr. Whiteson is right again. 3 significant figures for this one. 3 significant figures for this one. How many significant figures should your answer have? Your answer should have the same number of 3 significant figures. I'll answer your question in a second. As the number that has the answer should have the same number of significant figures as the number that you have multiplying or dividing. So 3, 3, this should have 3 significant figures. Now, someone asked for this problem right up here, one of your colleagues, that is, can you also write it as 43.7? And the answer is yes. If it's a small number, don't put 10 zeros after it. If this were 10 to the 10th, I'd probably accept it, but I wouldn't be happy. I might take off a point. But something like that. Now, notice I haven't taught you how to go from scientific to decimal, because why do an extra step? It's an extra thing you can get wrong on a test. So, but either way, because guess what? Dr. White knows the scientific notation. Would be all right on the test. Ooh, that reminds me. I better tell you something. And that is Dr. White is this close to the person who grades all the tests in this course, me. So when I tell you this, I'm going to grade it, that's how I'm going to grade it, and that's how I always have graded it. All right, round this off to 3 significant figures. Huh, is it with you or does everybody uh, answer in chat? If my audio has been going out, put yes. If my audio has not been going out, put no in chat. That's weird because mostly it's not. Uh, all right, hold on. Test, test, test. All I can say is half of you are, and this has never happened. Uh, try turning up your speaker. I can't, hold on, let me do a test first of all. Test, test, test. Number 9, number 9, number 9. All you people get off the grass. That comes from Woodstock, no. All right, for those, my Zoom has just told me my microphone is working right. I don't know, did you hear my test when it played it back for me? Anybody? Uh, I can't explain it. Uh, you might want to check on the internet. Zoom also. Uh, Another thing I'd recommend is not now, but later, if you have a separate webcam, not hooked up, that hooks into your computer or tablet, take the connection out and put it back in. Sometimes that helps give a better connection, or with your speakers, I guess, not your mic. Uh, but most of you are hearing me. Let's do something. Let me, hang in there. Dr. White's going to go high tech on you right now. Answer the question, can you hear me? All right, looks like the majority of you can. So that's a good thing. So if you're having audio problems, let me know. I'll research it. If I have today, I'm going to be busy until 4. So if not, you try Google. Oh, hold on. Let me do one thing and then we'll get back to work. All right, for those of you, this is for audio for the mic, but if you go to Google, Let me try. If you look on screen, let's see something. All right, everybody see on screen who is having problems? If you go to Zoom, what I did was in Google, why do I stop hearing audio on Zoom? And you can see here, uh, there's some answers. I'm going to let you read them on your own. Uh, and I would track it down that way because the majority of the people are hearing me. So if you still have problems, email me and I'll help you, or come to my office hour and I'll try and help you. All right, let's move on. We're talking about when you do a calculation dealing with significant figures. When the calculation is multiplication or division or and together, the number of significant figures in your answer is the same as the number of significant figures in the measurement, meaning the number that contains the fewest significant figures you're multiplying or dividing. So you look and see the number you're multiplying, dividing, which one has the fewest significant figures, and that's how many your answer should have. And you use rounding off, which we practiced this morning, to do that. So now I'm going to let you solo. I think you can do it. And let me put this in my calculator. And my calculator gives me the following number. And this is not the right answer. If you put that down in a test for this type of calculation, I'll take off 1 point and do not enough of them. You're going to lose a lot of points. So why don't you figure out how many, what's the proper answer based on significant figures? That's 3.66175. And have fun. And when you're done, give me a thumbs up. All right, looks like everybody's done. Are you done? Let's do this. How do you do this? This is a multiplication. You have the same number of significant figures in your answer as the number you're multiplying that has the fewest. So the first thing you have to do is figure out how many significant figures in 2.14. All non-zero numbers are significant. 1, 2, 3. This has 3 significant figures. All non-zero numbers in the second number are significant. There's a decimal. 1, 2, doesn't matter because they're all non-zero. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This has 5 significant figures. Which is lower, 3 or 5? 3 or 5? And 3. So that means your answer should have 3 significant figures. How do you round this off to 3? Keep the 3, keep the 6, keep the 6. That's my 3 significant figures. And then use 1 to round off. Somebody beat me to it. And 1, is that 4 or less or 5 or higher? 4 or less. So I'm going to drop that. And the correct answer using proper significant figures for that is 3.66. Let's do another one. And these are calculations. You're going to be doing stuff like this. And when I put this into my calculator, the number it gives me on my calculator, I'm always amazed how many. Is this. What would be the proper number using significant figures for that division, 9.175 divided by 2.1? Your turn. Hang in there, I'm trying something that I didn't have. I can do this now. And it looks like everybody's just about done, so I better get to work. All right. Wrong thing. Now, how do you determine how many significant figures your answer should have? You look at the number of significant figures in the numbers you're multiplying or dividing. And this top one, all non-zero numbers are significant. 1, 2, 3, 4. So that would be 4 significant figures. The bottom one, these are all non-zero numbers. So that would be 1, 2. And therefore, this is 2 significant figures. How many significant figures should our answer have? It has the same number of significant figures as the number you're multiplying or dividing. That's the fewest. So which is the fewest, 2 or 4? And hope we all pick 2. So now you have to round this off to 2 significant figures. How do you do that? There's a decimal here, doesn't matter. Keep the 4, keep the 3. Use 6 to round off. Is that 5 or higher, 4 or less? 5 or higher. So I'm going to drop all this and increase this by 1. And the correct answer for this would be 4.4. And that's how you do it. Oh, let's do one more. It's a little more challenging, but let's see if you're up to it. Hold on. And when I do this, my calculator gives me that answer. And this is 20, not 2.0. That's 20. So what would be the right answer for that calculation? And the new question for today is, can you hear me now? Good news, most of you hear me, like all of you just about. All right, I think everybody's done. Let's take a look. How do you do this? Now, how many significant figures does this number have? It has a decimal. All non-zero numbers are significant. That's 3. The 0 at the end with a decimal is significant. So that has 4 significant figures. Now this number, 20, has a non-zero number, but this 0 is at the end with no decimal point. PT is point. That means it's not significant. So this has 1 significant figure. And how do you round this off? This has 4. How do I round this off to 1 significant figure? I keep this, and this is the number I round off. Is that 4 or less, or 5 or higher? And 5 or higher. I'm going to drop all this. This gets increased by 1. So the answer to proper significant figures is this. And that's how you do it for multiplication division. Now, in my practice problems for this appendix A2 and A4, will you have the opportunity to do more practice problems, and I'll go through those in the lab later on, probably next week sometime. And let's continue. Now, one of the things that took me a while to wrap my head around, but I finally realized, yeah, they're right, but still at times I'm not sure how right they are, is for addition subtraction. In this class, you can do almost no subtraction at all. I can't think of any, but you will later on do addition. And addition when or subtraction or and subtraction, the answer has no more digits, significant figures to the right of the decimal point than are found in the measurement with the fewest digits, significant figures to the right of the decimal point. So what does that mean? When you're adding two numbers together, you have to look at how many significant figures to the right of the decimal. And when you add it up, the number that has the fewest significant figures to the right of the decimal indicates how many you have in your answer. Let's look how that works, because you'll be using this semester. Now, this is an addition, and if I make a mistake, someone tell me. And if you just put it in your calculator, you would get this number. And if you put this down, that would be wrong. Why? Because you look at the number to the right, look, I'm going to go Technicolor, of the decimal point. How many significant figures does each one have? This one has 2. This one has 1. So this part, you have to round off to the number that's the fewest, 1 significant figure past the decimal. And how do we do that? Keep the 4 and use the 1 to round off. Is that 4 or less or 5 or greater? It's 4 or less. So I'm going to drop that, and the correct answer for that addition using significant figures is that. Let's do another one. And if I add it up, this is the number I get when I use my calculator. Now, is that correct? Now, the first thing that it took me a long time to, yeah, I guess I understand what they're doing. This part here, you never round off in an addition. And the important thing is never. Anything to the left, this way of the decimal, you leave alone. This number to the right, it has the same number of significant figures as the number past the decimal right here as the fewest. So we look at this and this. We don't look on the left side of the decimal. This has 3 significant, this has 2, which is the lower number. Hopefully you have 2. So now you have to round this number only to the right of the decimal to 2 significant figures. Keep the 7, keep the 3, use that to round off. It's 4 or less, so I'm going to drop it, and the correct answer would be this. At first you'd say, well, this is 4, this is 3, how can this be 4? Well, for addition, it's a little funkier. That's the only way I can think of it, but it is accurate when you understand addition. And I'm going to let you have a try. Why don't you round this number off to the proper number using the addition rule for a rounding off rule? All right, I think everybody's just about done. I'll give you another 4 seconds. I'll throw in an extra second, 5, 6, 7, 8, done. All right, now the first thing you have to do is look at how it's an addition. And when you have an addition, you have the same number of significant figures to the right of the decimal as the number that has the fewest. Now, remember, zeros past the decimal are significant. So this has 2 significant figures to the right of the decimal. This has 3 to the right of the decimal, which is a smaller number. Hopefully I'll pick 2. So now you have to round this off to 2 significant figures to the right of the decimal. Keep the 7, keep the 1, use that to round off. All right, hang in there. There we go. And this is 2 or 4 or less, so I'm going to drop that. So the correct answer would be that. And that's how you do addition. Again, we will have more practice problems. You do them first. Remember I talked about yesterday watching the Blu-ray on riding a bicycle? When you see me doing it, it's not that hard. But when you try it all alone, you might fall off once or twice, but that's why you do practice problems. Now, remember I talked about exact numbers. Numbers obtained by counting or from a definition. When you're doing in math, either multiplication, division, or addition, exact numbers are never used to determine how many significant figures your answer should have. I'll say it again. Exact numbers are never used to determine how many significant figures your answer should have. And let's take a look at an example of how that works. All right, on test number 1, under your name, it will say use proper significant figures for all calculated answers. And if you see a problem like this, what do? Well, first of all, what are we trying to find? Degrees F. What are we given? 21.2 degrees C. Notice this is 3 significant figures. All non-zero numbers are significant. Well, degrees F equals 1.8 times degrees C plus 32. Well, I'm going to put in that. And now let's go to my calculator, my spreadsheet. All right, just help me out. Thumbs up, people. Do you see the spreadsheet on your screen? Thank you. All right, my answer would be 70.160000 on my calculator. And if I go back, my calculator gives me something like this. And what's the right answer? Well, if we look here, 1.8 is an exact number. 32 is an exact number. It's part of a definition of that calculation. But this, the 21.2, is three significant figures. And therefore, my answer should have three significant figures. So I'm going to let you all round this off, 70.16000, to three significant figures. All right, looks like everybody's done. Let's do this. How do we round this off to three significant figures? 7 I keep. Notice the 0 is between two non-zero numbers, and also you have a decimal. So this is significant, that's 2. And the 1 is, the 6 is the number I use to round off. Is that 5 or greater, or 6? Yeah, 5 or greater, or 4 or less? It's 5 or greater. So I'm going to drop this and this and this. So I'm past the decimal. I'll increase this by 1. And the correct answer would be this. Or if you had it on your scientific note calculator, it would look like that. You had it in scientific notation mode. And that's how you use exact numbers in a formula. They have no role in determining significant figures. The only number in this case for this formula is the degree C. That's a measurement that has three significant figures. And that's how you do it. And let me say it again. When you have a formula, the numbers in the formula right here, 1.8 and 32, are exact numbers. Exact numbers play no role in the calculation. Therefore, the only thing that plays a role is this number, which has three significant figures. So your answer, when you do the multiplication, addition, and multiplication, should have three significant figures. And that's what you have. And that's how you do it. Oh, that's not what I want. All right, now, couple things. What happens? Oh, hold on. There we go. What happens if you do a couple calculations, which we will be doing? When we get to that point, I will teach you there are two philosophies when you're doing a series of separate calculations, separate steps. One is you round off at each step using the multiplication, division, or addition rules I taught you. Another philosophy is you do it at the end. Now, I'm of the mindset I do it at each step. But on a test, I will calculate it both ways, rounding off at each step and rounding off at the end. Now, a lot of times they're the same number. Sometimes they're not. And when they're not, either way will be correct on my test because I'm not going to force you to do it the way I do, but I do it that way. And I've done calculations where if I made a mistake, I've just blown about, $400,000 in company money for chemicals and other things, which means I would have been fired like that. It's never happened because whenever I do those type of calculations, I'll do it, let it sit for a day or two, do it fresh again, compare the two numbers, and they better be the same. They always are because I take my time. Speaking about time, we're almost out of it. All right, couple things. Remember tonight, if you need help, I have my office hour on Zoom from 6 to 7:15. Remember, it's a different log on than the Zoom meeting we're having now. Tomorrow, we're going to have our first lab. And what does that mean? It means, give me time while I log into Blackboard. All right, if you look at Blackboard, which you should all see, where it says assignments, click on that, and you'll see the first lab is the safety lab. And I have it both as a Word document and a PDF file. Now I've put here how to do scanner. As the app you can get. No, don't pay money for that. Get the free version. It works just as good. And I also give instructions both how to upload later on. We're going to go through this lab tomorrow. Don't forget, if you haven't uploaded your signature sheet, here they are. Upload them as a PDF file. Because if you don't, you can't take the first test. So please get that in ASAP. And with that, guess what? It's time for Dr. White to say goodbye. And I will. Goodbye. Gang gesund, be healthy. That's what that means in Yiddish. And I'll say goodbye. I'll see you tomorrow. Unless you come.